All right, here we are meeting again for 6 through 10. So this will be your 1129 do know. So if we're going through our steps, it's find the figure or table, circle the variables within. If it's a graph, you find the intervals. Do the math problem, find variable, your unknown. Okay, so based on figure 3, so that's where I'm going, which is right up here. For SIC, a 5 gram per centimeter squared increase in areal density corresponds to which amount of decrease in DOP? So I'm going to go first to figure 3. Then I'm going to find SIC. So I know this is the one that I'm looking at right here, this line. Okay, now a 5 gram per centimeter increase in areal density. So that would take me from, this is 2.5 to 7.5, that's 5. So one of these buckets right here, 7.5 to 12.5. So from here to here and here to here. So these are approximate. Okay, so let's look at here. So this is about 4, just under it. And this right here is just over it, over 3. And then let's just double check here. So if we follow the slope for where that would go, this is about 2 and this is about 3. So it looks like it's approximately a 1 centimeter decrease. So that means our answer there is C. In experiment 2, add an areal density of 12.5. Approximately what was the ratio? So we'll have a fraction of DOP for SIC to DOP of TIB2. So first I need to find out where experiment 2 talks about it. So that's again going to be figure 3. So I can go straight back. So what's the ratio? So at 12.5, that's this line right here, and I need SIC to TIB2. So TIB2 is this line right here. So at SIC is approximately 3, and TIB2 is approximately 1.5. So 3 in relation to 1.5. Let's simplify these numbers. So if I divide both things by 1.5, I'm going to get 2 over 1. So my answer to 7 is C. In experiment 1, so that means I'll be looking at a new figure, when launch velocity increased from 900 to 1400 DOP. So in experiment 1, when launch velocity increased from 900, so launch velocity went from 900 to 1400. So this range, what did DOP do? So I'm going to highlight it through so I can look. So this is approximately 2.5, and right here is approximately 6. So 6 minus 2.5, 3.5. So 6 and the relationship of 2.5. What are these about? So I'm going to round this to 3. So 6, it went from 3 to 6. It actually increased, so that would be 3 goes to 6, and that would be I'm not going to round up. That's too much rounding. Let's look at these actual values. Okay, this is 900. That's actually 2.5 seems a little high. Let's maybe say 2.2. So if I went from 2.2 all the way up to 6. I'm going to actually round down. So that would be tripled. But then your distractor is doubled. So C is the distractor. I know this because 2.2 could be rounded up depending on estimates. Alrighty. Nine. Let me just make sure I did all of these because I forgot one last week. So I did 6, 7, and 8. Perfect. Okay. Number 9. Based on figure 2, the average temperature for the entire fall season was closest to. The average. So that September to November, that means that this requires you to find the average. So that what that means I have to do is I have to take September plus October plus November and then divide by how many months there are, which is 3. So based on figure 2, and I'm looking at site A. So I'm looking at the white squares here. So September was about 15, right? October is about 10. November is about 6. So 21, 31-ish, maybe 32 if we make this 7. Okay, but I don't know what, 31. So it's somewhere between 31 and 32. I don't know what these are divided by 3. Those aren't even, so I'm going to do the ones that I know. So 30 divided by 3 and 33 divided by 3 are going to be the outskirts. So x will be somewhere in here. So that will be 10, and that will be 11. So my temperature is going to be somewhere between 10 and 11. The closest one we have there would be A for 9. So if you don't get the exact value, you pick the closest. And all that means is you estimated too wide on the graph. Okay, according to figure 1, so I'm going to go to figure 1, the daily milk production at site B in August was approximately, now let's look at my answer choices here because I'm seeing a lot of months, January, June, January, June. So August, January, and June are the 3 things that I need to take in from figure 1. So at site B. So August in site B was about 26. January was about 36. And June was about 29. Okay, so I need the relationship here. So August to January is 26 to 36, and then August to June is 26 to 29. So, and again, it's looking for percent, so that's x over 100 equals x over 100. So 2600 equals 36x, and 2600 equals 29x. And you're just going to estimate these values. So you don't really need to solve them. So I have 26 over 36 and 26 over 29. This is almost 100% for our intents and purposes. That's a really high percentage. So we can cross off the June ones because it was definitely not 50 or 75% of those. Now 26 is not half of 36 either. 26 isn't half of either of these numbers, so we can cross off the 50s right away. So that means between we're C and D. Now 26 over 36 has a 10 milk jug difference, so that is about like if we rounded this up and down, that would be 25/40. Then you just need another 15, so that would be right to 75. That's just process of elimination, thinking of your halves and your wholes. Okay, based on the data for January in figure 3, the ratio of daily milk production in conventionally to daily milk production of organically fed. So I'm looking at January, and then I'm looking at figure 3. Let me make sure that figure 3 is going here. Yep. Figure 3, and I'm looking at January, and I'm looking at conventional and organic. So January was 26 organic, 36 conventional, and we're just going to try and drop these down. So, and we're looking at conventional first and then organic. So that would be 36 to 26, and we can divide those by 2, 18 to 13. How can we reduce these? So about 18 to 13, so we can change these numbers a little bit because they're just estimations. So let's see. 36, 25. Let's do 35 to 25. We'll just take one off of each because then they're both divisible by the same number. So 7 to and do we have an option here? We have 7 to 2. That's too much. 5 to 1 is still too much. Well, I guess we can divide 36 by 4 and make that 24-ish. Let's do that. So, again, these are going to be all estimations. So, divide that by 4, it's 9 to 6, and I'm going to cross that again. We'll do that. So, 3's, 3 to 2. 3 to 1 is still too small. 4 to 3 would probably be the closest. So, that one is just finding the estimates that you can have here. Like, let's look at the bar for these ratios, and then you serve it that way. But the correct answer to number 11 is C.